Yeah, hello everyone. So this is Mallikarjun from Department of Tripoli, working as Assistant Professor, IARE Engineering College, Hyderabad. So today we are going to discuss about the subject called DC machines and transformers. So where we are going to learn about what are the different types of DC machines we have, like what is a generator, what is a motor, what is the working principle of it, what are the different types of DC generator and what are the different types of DC motor, what are the expressions involved in it. These are the different things what you are going to study. And we are also discussing about transformer, what is the working principle of a transformer, what is the EMF equation of a transformer, what are the types of transformers we have, and how this transformer is going to work at no load and also different load conditions. We are going to discuss about all these things in this particular course called DC machines and transformer. And the first topic what we are going to discuss in case of a first module is DC generators. DC generators. So what is a DC generator? What are the different constructional parts of it? So what is a yoke? What are the different things that are present in case of that particular generator? And similarly, we are going to discuss about the working principle in this particular class. So before going to discuss about the content, what is present in this particular course, so I want to make a note of the course outcomes. That is what the student is going to learn after the completion of this particular course called DC machines and transformers. So there are 6 number of COs has been designed for this particular subject, and the CO1 describes about the load sharing capabilities and reliability of electrical machines. That is under various load conditions, how my electrical machine is going to work. That is various load condition is nothing but what half load, full load, 1/4 load, 3/4 load, different conditions, how my machine is going to work. This is the first thing what you are going to get. The second one is by using the different concepts of complex algebra, phasor operations, principle of electromagnetic circuit theory, we need to analyze the performance of each and every electrical machine. Either it may be DC generator or DC motor. In order to analyze the performance, you need to go through certain concepts where we need to draw the phasor diagrams. We need to rewrite the expressions in the form of EMF or back EMF or torque. This will give you an idea about CO2. And CO3 is nothing but it to demonstrate the working of a linear machine as a generator. That is how this particular generator is going to work. So what are the different laws I need to use? What is Faraday's law of electromagnetic induction? What is Lorentz law? We are going to discuss about these things in case of C1 number 3. And coming to C1 number 4, here we are going to discuss about identifying the various control strategies for calculating the performance parameters and voltage regulation. So what is the definition for voltage regulation? And how we need to calculate the value of voltage regulation of particular parameter, and what are the different parameters I need to calculate. That is what is the value of E0, what is the value of V0, that is voltage, terminal voltage and voltage under no load. This we are going to learn in case of C1 number 4. And coming to the C1 number 5, here again we are going to define the performance of different machines. And the last thing CO is completely regarding was transformers. As we have discussed earlier, there are different types of transformers. One is single phase and 3-phase transformer, and there are also auto transformers depending upon the connection. So what are the equivalent circuit diagrams of this particular transformers and how they are going to play a major role. So these are the 6 outcomes which will play a major role, and these are the different things what you are going to get after the completion of this particular course called DC machines and transformers. DC machines and transformers. Now we enter into our first topic called generator. So what is the general purpose of having a generator? A generator is nothing but what? Which will provide some amount of electrical energy as an output. Yes or not? It is an electrical machine which will give some amount of energy in the form of electrical energy. But if I need the output in the form of electrical, first I need to give some input to that particular machine. So the general definition of this particular generator is it is a machine which converts mechanical energy into electrical energy. It is a machine which converts mechanical energy into electrical energy. And if I want to know the concept, that is how this mechanical energy is converted into electrical energy. So there is certain working principle behind this particular conversion. That is one form of energy is converting into another form. The input is mechanical, the output is electrical. But how this conversion is going to take place, that can be known by using the working principle of this particular machine called generator. That is, we will use a Faraday's law of electromagnetic induction here. Faraday's law of electromagnetic induction. Faraday's law of electromagnetic induction. By using this particular law, you are going to know how this conversion is going to take place in case of a generator. In case of a generator, the same thing is present in the second point here. DC generator. DC generator is the one which generates electricity using the principle of what? Faraday's law of electromagnetic induction. Now coming to the statement of Faraday's law of electromagnetic induction. Whenever a current carrying conductor is placed in a magnetic field, a varying magnetic field, an electromagnetic force get induced within the conductor. So let me take a magnetic field. So this is my magnetic field where it consists of a north pole and south pole. So according to the property of a magnet, always the flux lines will pass from north pole to south poles like this. Now what I am doing, I am taking a conductor. So what type of conductor it is? A conductor which is used to carry some amount of current in it. Yes or not? Either it may be made up of aluminium or it may be made up of a copper, whatever it may be the material you choose. So now I am taking a conductor and this conductor is placed in case of this particular variable magnetic field. So what will be induced? An EMF will be induced within the conductor. And EMF will be induced VMF conductor. EMF is nothing but what? Electromotive force which can be considered as a voltage. This voltage is going to induce an amount of current in it. And this current or voltage can be used for the supplying. So what is the working principle of a generator? Generator works on the basic working principle called Faraday's law of electromagnetic induction, and the statement of Faraday's law of electromagnetic induction is whenever a conductor is placed in a variable magnetic field, an electromagnetic force will get induced within the conductor, and this induced EMF is measured with the help of a right hand, Fleming's right hand rule. Now coming to the construction part, you can see a construction part in this particular thing. So what is this particular thing? It consists of a field winding. Yes, it consists of a field winding. It consists of a pole shoe, yoke or a frame, commutator, interpole, armature conductors, shaft, and this particular area which is in the form of round, it is called as a yoke. So these are the different components of DC generator which are present on this particular left side. So what are these? One is nothing but a yoke. Another is nothing but a magnetic field system, and next one is armature core, next one is armature winding, commutator segments, function of that particular commutator, what is shaft, pole shoe, poles and bearings. So we will discuss about what is a yoke, what is the function of it, and what type of magnetic field system is used in case of this particular construction of a DC generator, what is armature core, what is the type of winding used in it, what is the purpose of a commutator and what is commutator function, what is the purpose of poles here, what is the purpose of bearings, what is the purpose of pole shoe. We will discuss about all these functions in detail from the next slide. Now the first and foremost part is nothing but what? Yoke. So yoke is nothing but what? In this particular diagram, the outer cover which is present or which is used to protect this particular parts which are present in case of this particular machine can be called as a yoke. And the definition for yoke is the outside frame of a DC generator is a hollow cylindrical made up of a cast or rolled steel. So whether the yoke can be made by using a cast steel or a rolled steel. And what is the main purpose of having a yoke in case of a construction of DC generator is in order to support the field poles. That is, there are certain number of poles which are present in the form of N and S in case of this particular construction. Yes, in order to protect this, in order to provide the mechanical support to this particular structure, we need to use the yoke. And yoke is an outer cover which is used to provide the mechanical support to the system. And it will act as a protective cover for the total machine which you use it to. Why? Because there might be a change in the different environmental conditions at different point of time. In order to protect our particular machine parts like poles, pole shoes or the different windings which are present in the particular slots, we need to have a yoke there. And it also acts as a channel for the magnetic field produced by the field core. So there are the two objectives which are given by the yoke. One is it supports the field pole core and it will act as a protective cover of a machine. And the next one is it will also act as a channel for the magnetic fields which is produced by the field coil. Which is produced by the field coil. And the next important component of DC generator is the armature core. The armature core. So the armature core of a DC generator is positioned on a shaft and pivots between the field poles. Between the field poles, it features slots on its exterior surface where the armature conductors are installed, and this armature core is completely made up of a iron laminations that are isolated from one another and are securely attached together. So what is the main purpose of having this particular armature core? This armature core is mainly used to install the armature conductors in it. What is the purpose of having armature conductors in it? In order to produce a magnetic field flux in that particular core, you need to use a conductor. Why? Because conductor is an element which you use to pass some amount of current in it. If I want to produce a magnetic field in a particular core or else in a particular area, I need to supply some amount of current to that particular conductor. If I want to produce some amount of magnetic field, I need a conductor there. Where I need to place those conductors? These armature conductors are placed in case of a armature core. In case of a armature core, and this armature core is completely made up of what? It is completely made up of a iron laminations. Iron laminations which are isolated from each other. Coming to the next component, that is armature winding. So without winding, there is no passage of current and there is no production of the magnetic field in case of a core of a DC generator. Yes or not? So what type of winding is used and what are the different types of windings I can accommodate in order to produce the magnetic field in case of a DC generator. So what is our next topic? That is armature winding. So insulated conductors are inserted into the slots of armature core. As we have discussed earlier, what is the purpose of armature core? In order to have a slots. What is the purpose of slots? In order to produce a winding in it. What is the purpose of winding? In order to pass some amount of current in it. What is the purpose of having passing some amount of current? In order to produce a magnetic field. And this armature winding is completely inserted into the what? Inserted into the slots of the armature core, and these wires are properly connected. And the link number of conductors is known as what? It is known as a armature winding. So the proper arrangement of conductor should be done. That is, each and every slot need to have an winding in order to produce some amount of magnetic field in it. And there might be different types of windings we can use here. One is nothing but a lap winding, and another is nothing but what? Wave winding. One is nothing but a what? Lap winding, and another is nothing but what? Wave winding. These are the different types of windings where we can accommodate these windings in case of a armature core in order to produce some amount of magnetic flux in the core. And we will discuss about the different types of windings called lap winding and wave windings in the next classes. Coming to the next important component of this particular generator is commutator. Next one is nothing but what? Commutator. So what is the main purpose of having a commutator? Is nothing but the commutator will act as a rectifier. So what is a rectifier? A rectifier is the one which you use to convert the alternating magnetic field of the armature winding into a direct voltage that runs through the load terminals. So rectifier is nothing but what? It is completely an inverse of a, or the reciprocal of what? Inverter. Also, what is the purpose of an inverter? Inverter is the one which takes DC and gives the output in the form of AC. And commutator is nothing but it is acting as a rectifier, where the rectifier is the one which takes input as AC and the output will be given in the form of a DC here. And the shape of the commutator. The commutator is constructed above wedge-shaped copper segments that are isolated from one another and the shaft by mica sheets. So here the insulation is provided between the each and every commutator segment with the help of this particular insulation material called mica. And each commutator segment is connected to what? Is connected to the one of the armature coils ends. One of the armature ends. So what is the main purpose of having a commutator? The commutator is nothing but it will act as a rectifier. And what is the main function of having a rectifier? It converts AC into DC. AC into DC. And what is the material that is used to provide the insulation between this particular commutator segments? We can use mica as a insulation. Mica as an insulation. Coming to the next important component of this particular DC generator is magnetic field system. Magnetic field system is DC generator's magnetic field system serves as its stationary component. It generates the primary magnetic flux in the generator. It is made up of a large number of pole cores fastened to the yoke with field winding calling about the pole shoe. So what is the magnetic system used here? The main use of having a magnetic field system is nothing but what? In order to produce some amount of EMF in it. How? As we have seen in case of this particular construction diagram here, there are 4 number of poles here, where N is indicates as a north pole and S will indicates as a south pole. S is indicating as a south pole, and you can see here the edge of this particular pole, the edge of this particular pole, which is represented in this particular shape. In this particular shape, this is called as what? This is called as a pole shoe, and this is called as a pole core, and this total it is called as what? Pole. So what is the number of poles that is used in case of the construction of an example here? There are 4 number of poles. There are 4 number of poles, and you can see the commutator segments which is used in this. It is present in the form of a ring, and where it is divided into different commutator segments like this. And what is the insulation that is used here? The insulation used between each and every commutator segments is what? Mica, what we have discussed earlier. And there is one shaft which is present here. Shaft is nothing but what? In order to make my things to rotate. And there are some number of armature currents that are present here. What is the purpose of armature conductors here? In order to pass a amount of currents. And what are these chain type structures which are present in case of this particular thing? So these are nothing but these are used to place the winding, and this is called as armature conductors. These are called as what? These are called as armature conductors. So what is the purpose of armature conductors? In order to pass some amount of current through the particular element, we need to have these armature slots there, and where these armature slots are placed in case of a armature core. In case of a armature core. And this is how the magnetic field is produced here. And what is the number of poles from due to the magnetic field created? There are 4 number of poles: North Pole, South Pole, North Pole and South Pole. North Pole and South Pole. So this is regarding what? This is regarding the magnetic field system. Coming to the shaft shoe. Here the shaft shoe or pole shoe which is used has 2 objectives mainly. One is it provides the support for the field coils. So there are certain number of field coils that are present in case of a construction of a DC generator in order to provide the mechanical support. In order to provide the mechanical support for the field coils, I can use this particular pole shoe. And what is the and not only that, it also used to lower the reluctance of the magnetic circuit by expanding its cross-sectional area. So what is the need of lowering the reluctance of magnetic field by expanding its cross-sectional area is nothing but what? In order to reduce some amount of losses. So what type of losses? Eddy current losses. So eddy current losses are the one which are produced in a circuit due to some unwanted currents which are flowing in that particular area. So due to unwanted circulating currents, I am going to get some those unwanted circulating currents which are circulating in case of machine are considered as eddy currents, and the losses which are produced due to them are considered as what? Eddy current losses. Eddy current losses. And in order to reduce the effect of this particular eddy current losses, I need to use pole cores, and these pole cores are constructed of thin sheet steel laminations. So what is the purpose of having a lamination here? In order to reduce the eddy current losses. eddy current losses. And coming to the next point, the field coils are linked in series to create alternating north and south poles in the rotating as the current flows through them. So as we have discussed about the definition here, so it is a variable magnetic field where the magnetic field is going to change. Why? Because there is a production of a dynamically induced EMF which is completely based upon the Faraday's law of electromagnetic induction here. So the field coils are linked in series to create what? To create the combination of north pole and south pole in the rotating direction as the current flows through them. So these are the two main objectives of the pole shoe or shaft shoe which are present in case of a construction of a DC generator. So it provides the mechanical support for the field coils. It also lowers the value of reluctance of a magnetic circuit by expanding its cross-sectional area. And not only that, in order to provide the eddy current losses in this particular machine, we need to use some steel laminations. Coming to the next point, that is shaft. So what is a shaft? How can you define the component called shaft in case of a DC generator? The shaft is a key component of a DC machine because it produces torque. Which causes the rotation. And the material that is used to make this particular shaft is nothing but we can use mild steel, which has the high braking mechanical strength. And the shaft is a component of DC generator that influences the generator's ability to transport mechanical energy. And the shaft is key to the commutator segments, cooling fan, armature center, and also the other spinning components or rotating components which are present in case of a DC generator. So what is the material that is used to make this particular shaft? The material used is what? The material used is a mild steel. So in order to protect it from the different environmental conditions, like that there may be a change in the temperature or there may be a change in the humidity, in order to protect it from the different conditions, this material is made up of a mild steel which has high mechanical braking strength. So the material whatever you are choosing in order to construct this particular shaft should have a high mechanical braking strength. And it is a component of DC generator which influences the generator's ability to transport mechanical energy. And the shaft is the one which is key to what? It is key to a commutator, it is key to a cooling fan, it is a armature center, and also other spinning or rotating components. And the next component of a DC generator is pole shoe. What is pole shoe? A pole shoe is a plate which composed of iron or steel that spreads the magnetic flux and prevents the field coils from falling. So what is the main purpose of having a pole shoe? Already I have shown you where the presence of pole shoe is present in case of this particular machine. So if this is my pole which is present or which is designed in case of which is formed in case of this particular machine, the structure which is represented in this form of curve is called as what? It's called as a pole shoe. And what is the purpose of having this particular pole shoe here? The pole shoe is a plate composed of iron or steel that spreads the magnetic flux and prevent the field coils from falling. So what is the main purpose of having a pole shoe is nothing but in order to spread the magnetic field. The shape of this particular coil pole is made like this, and this particular shape is called as what? It is called as a pole shoe. And this pole shoe is completely made up of either it can be made up of a iron or else it can be made up of a steel. Just in order to prevent the field coils from falling and in order to spread the magnetic flux in case of that particular machine in a uniform way, we can use this particular pole shoe. Coming to the next one is nothing but poles. So poles are nothing but these are the important, this is an important part which is present in case of a considered as an important component of a DC generator because the poles are the one which helps maintain the field windings in a excellent shape. And these windings are generally coiled on poles and linked in a certain order to the armature windings. As a result, these poles attach the welding procedure to yoke using screws. As we seen in the construction diagram, earlier here. So you can see where is the presence of this particular thing. This is nothing but a yoke, and the poles are attached to the yoke here. The same thing is discussed in this particular thing. Poles are nothing but they are directly screwed to what? They are directly screwed to the yoke by using certain screws. And what is the main purpose of having a poles? In order to help maintain the field windings in the excellent shape. These windings are generally coiled on the poles and linked in a certain order to the armature conductors. Now coming to the next important component, that is nothing but what? Bearings. So what is the purpose of bearings? Bearings are mainly used to reduce the friction error. So what is the meaning of friction? So whenever there are two objects which are trying to collide with each other, there may be a chance of having a friction between those particular objects. So in order to reduce that particular friction, you can use certain bearings, or else you can use certain grease, or else some other elements in case of that particular bearing, in order to reduce that frictional error to a certain extent. Now we will see what is bearings and what are the different bearings that are used here, and what bearings is made up of, and what is the purpose of it in case of a DC generator here. So bearings are used in a system to ensure that various parts of DC machine moves smoothly. That is, if I don't provide bearings with a proper functioning, what will happen is nothing but some noise will be generated without using of proper bearings in it. So in order to reduce the friction between the elements, as it is a rotating part, there might be a friction effect. In order to reduce that, we need to use the bearings here. And as a result, the system components require what? Less frequent greasing, which lasts longer. Roller bearings and ball bearings are the two most popular types of bearings that are used in case of a DC generator. So bearings are nothing but what? Those are mainly used to reduce the frictional error in a machine. So what is frictional error? Frictional error is the one which will be produced in a machine due to the rapidity that has been occurred in case of a rotating objects. So we need to reduce that particular extent by placing a grease in it, by closing some other things. And there are two different types of bearings that can be used here in case of a DC generator. One is nothing but a roller bearings, and the other is what? Ball bearings. These are the two types of bearings which are used to reduce the frictional error to a major extent in case of a DC generators. So whatever it may be a rotating machine, there will be a different, due to the rapidity which is maintained between the two equipments in that, there will be a frictional error, and in order to reduce the frictional error to up to certain extent, we can use this type of bearings. And what are the two types of bearings we have? One is nothing but a roller bearings, and the other is nothing but what? Ball bearings. One is nothing but what? Roller bearings, and the other is nothing but what? Ball bearings. So these are the different components of DC generator. And what is the working principle of this particular DC generator? Faraday's law of electromagnetic induction. Now we will go with the working principle. So according to the Faraday's law of electromagnetic induction, already we have come across the statement: whenever a current carrying conductor is placed in a variable magnetic field, or a conductor is moved in a magnetic field, and EMF gets induced in the conductor. So what is the structure of this particular thing? So let me say that this is nothing but my magnetic field, which is A, where N is the north pole and S is nothing but the south pole. So according to the property of a magnet, the flux lines will pass from what? North pole to south pole. So whenever I am placing a conductor in this variable magnetic field, this conductor, an EMF will be induced within the conductor. And in order to know the direction of this particular induced EMF, we need to use Fleming's right hand rule. In order to know that whenever a conductor is placed in this particular variable magnetic field, an EMF will be induced within the conductor. But if I want to catch the inducer, or if I want to know the place where the amount of EMF is induced, I need to use what? I need to use Fleming's right hand rule. I need to use Fleming's right hand rule, where thumb indicates the motion of a conductor, index finger indicates the direction of a magnetic field, and this middle finger indicates the direction of induced EMF. That is, I need to place the fingers in such a way that the thumb indicates the motion or movement of a conductor, and the middle finger indicates the direction of induced EMF, and the index finger indicates the direction of a magnetic field. And by using Fleming's right hand rule, we will know the direction of induced EMF, and then we can collect the induced EMF by using that particular thing. Coming to the next point, the magnitude of induced EMF can be calculated from the EMF equation. So there is an expression for EMF equation of a DC generator. So we need to calculate, it is a mathematical expression, you need to calculate what is the amount of EMF induced in case of a DC generator here. So if the conductor is provided with a closed path, the induced current will circulate within the path. Yes, in a DC generator, this field coils produce what? Magnetic field, and the armature coil rods are rotated into the field. So what are the different things what we have stated up to now? We have discussed about what are the different components of a DC generator. What is yoke, what is a magnetic field, what is pole core, what is pole shoe, and about the different components which are present in this. And we have known about the working principle of DC generator. That is, the working principle of DC generator is completely based upon what? Faraday's law of electromagnetic induction. We have come across the statement of this, that is, whenever a conductor is moving in a variable magnetic field, what will be induced? An EMF will be induced within the conductor. And in order to know the direction of induced EMF, what we need to use? We need to use Fleming's right hand rule, where thumb indicates the motion of a conductor, index finger indicates the direction of magnetic field, and the middle finger indicates the direction of induced EMF. So what is conductors now? Conductors are nothing but what? An electromagnetically induced EMF in the armature conductor. As just now we have discussed about what is Fleming's right hand rule. So what is the need of having this Fleming's right hand rule? In order to know the direction of induced EMF in case of DC generator, I can use this Fleming's right hand rule. Now this is the simple loop. This gives an idea about the working of a simple loop generator here, where we will discuss about this particular thing in the next class. So what are the different things what we have stated here? We have discussed about what is a DC generator and what is the main working principle of it, and we have discussed about what are the outcomes of this particular thing. So what is the working principle of DC generator? Faraday's law of electromagnetic induction. So what is the statement of it? Whenever a conductor is placed in a variable magnetic field, and EMF will be induced within the conductor itself. And in order to know the direction of induced EMF, what is the law I need to use? I need to use Fleming's right hand rule, where thumb indicates the motion of a conductor, index finger indicates the direction of magnetic field, and what is the next one? Middle finger indicates the direction of induced EMF. Coming to the components. So there are the different major components that are used in case of a generator in order to produce the EMF here as an output. So what are the different components? One is nothing but a yoke, armature core, armature winding, commutator segments, shaft, pole shoes, poles, and bearings. And we have discussed about the importance of each and every component which is present here. What is a yoke? What is the purpose of it? What is armature core? What is armature winding? What are the types of armature windings we have? And what is the material that is used to make an commutator segments, and what is the insulation that is used between the different commutator segments here, and what is the main purpose of having a commutator in case of a DC generator. We have discussed about functioning of shaft, pole shoe, what are poles, how to reduce the frictional error in case of a DC generator, and we have discussed about the working principle again, and we will discuss about the working principle of this particular simple generator with respect to this rotation method in the next class. Thank you for the day.
Like, share and subscribe. Hit the bell icon for more updates.